Hello students, welcome to the next session of Engineering Mechanics. This is Professor Vidyasagar Mugi. In this session I will continue with some more examples on applications of Varignon's theorem of moments. So to begin with, what you can see in your screen is the question: force acting on 1 meter length of dam as shown, neglecting weight of the dam, determine the resultant force acting on a dam. Find the point of intersection of the resultant with the base of the dam. Now to understand this, firstly you should know that for a dam to be stable, a dam is nothing but it is a water retaining structure where dam is constructed to store the water. So how the dam fails? So one possibility of the dam failure is the dam may slide like this, it may slide like this, or it may tilt like this. So in order to avoid those failure of sliding of the dam and overturning of the dam, we have to ensure that the resultant of the forces acting on the dam should pass between the middle third portion of the base of the dam. Now what is that middle third portion? Now if I extend this, if I show the base line like this, now this is the base portion of the dam, and if I call this as B, I am drawing this part here, enlarged version. If the base is taken as B, then the resultant of all the force, that is when you find out Fx force and Fy force, the resultant of this Fx and Fy, this resultant should pass within this base width B such that if I divide this base into three parts, this is B by 3, 1/3 of B, this is 1/3 of B, and this is 1/3 of B. So when I divide this base into three parts, the result should pass like this. It should pass like this. If the resultant of the forces acting on the dam passes between this middle third portion, then the dam is considered to be safe. So what is the condition for the dam to be safe is the value of resultant, the intercept. So this distance where the resultant cuts, if I call this as x, if I call this as value as x where the resultant cuts, then the value of this x should be such that it should be greater than 1/3 of B and smaller than 2/3 of B. It should be greater than 1/3 of B and smaller than 2/3 of B. Then the dam is said to be what? It is said to be safe. So in this particular problem, hope you are understood with the explanation. So this is a condition whether to determine the dam is safe or unsafe. Now making use of this, now in this problem it is to be known that whether the dam is safe or it is unsafe. Now how will we find that? We'll continue. So if you see the dam here, base width is 6 meter. The inclination given here is 60 degrees. One force is acting at a distance of 2 meter from the base, 50 kilonewton. One force is inclined, which is this force is perpendicular to this line, and the distance is 1.25 meter, and the top width is called as top width is 2 meters. This top part is called as the top width, this is called as the bottom width. Now firstly, in order to determine what is magnitude and direction of resultant, what we want, we need what are the forces in x direction and what are the forces in y direction. To know that, firstly see what are the forces. Now this force is acting purely in x direction, so need not resolve. This 120 kilonewton is acting purely in y direction, need not resolve. This 30 kilonewton is making some inclination. Now what is that inclination? You have to find out. If I draw the line here and if I mark this as angle, now I should know what is this angle theta. Now I'll write this as theta. I should know what is this angle theta. Now to determine the theta, what I'll do is I'll extend this line such that what is happening here? this is forming a right angle triangle. Now if this is 30, this is 60, this is 90, what is this angle? This angle is 30 degrees. Now if this angle is 30 degrees, what is the opposite angle? Opposite angle is also 30 degrees. Now if this angle is 30 degrees, what is this angle? This angle is also 30 degrees. So angle made by this force is 30 degrees. So when I resolve this force, so one force is making the vertically downwards and one force is making vertically leftwards. So this force I'll call as 30 sine 30 and this is 30 cos 30. Now what I'll do is I'll draw this figure once again because we need that, and we are taking moment with respect to what? This O point. We are taking moment with respect to O point. So that is, we are determining the resultant acting on the dam with respect to point O. So when you take the moment of these two forces, okay, I'll come to that later. Now that you have understood how we got 30 degrees, we'll move ahead. First we will find summation Fx equal to, what are the forces acting in x direction? This 50 kilonewton is acting rightwards, so this is plus 50, and this 30 cos 30 is acting leftwards, so this is minus 30 cos 30. So we'll get this force as summation Fx will be equal to 24.02 kilonewton. Similarly, I'll find summation Fy. Summation Fy equal to, now what are the forces? This 120 is acting downwards, 120 is acting downwards, so minus 120, and this 30 sine 30 is also acting downwards, so minus 30 sine 30. So this will be equal to, I'll get this as minus 135 kilonewton. Now that I have got Fx and Fy, I'll calculate what is resultant. So resultant is summation Fx square plus summation Fy square. Then I'll get the value of R as 137.11 kilonewton. Now we got what is resultant, magnitude of resultant, we got what is Fx, what is Fy. Now we have to calculate what is alpha. Now value of alpha is tan inverse of summation Fy by summation Fx. So we'll get alpha as 79.9 degrees. So we got these values. Now next, taking moment about point O. Now to determine the position of resultant, we require moment about point O, so I'll call that as M about O, MO. Now moment about this point. Now how will this, I'll draw this diagram once again here. This 50 kilonewton is acting here, distance is 2 meters. 120 is acting here. What is the distance? Distance is 2 meters, about point O. Now this force is making two forces like this. This is 30 sine 30 and this is 30 cos 30. Now what is the perpendicular distance of this? We need to know what is this distance. I'll call this as A. And what is the perpendicular distance of this? I'll call this as B. Now how will I calculate that? To calculate that, I should require this. I know this length. So what I'll do is I'll draw one more triangle here, which is making 60 degrees. This is 1.25 meter. This we know from the question. Now this 1.25 I know, and I know what is this 60 degrees. Now to calculate this, I'll call this as x1, I'll call this as x2. How will I calculate x1 and x2? So x1 and x2 is calculated as, what is opposite upon hypotenuse? Sine 60 is equal to what? Opposite upon hypotenuse. Opposite is x1 upon 1.25. So what is x1 equal to? So x1 equal to, I'll get as 1.08 meters. Similarly, what I'll do is I'll calculate what is x2. So x2 is what? Cos 60 equal, that is base upon hypotenuse, that is x2 upon 1.25. So I'll get what is x2 equal to. x2 equal to 0.625. Now what is this x2? x2 is here. This is x2. But what is the perpendicular distance of this force? It is a. So what is a distance? So a distance is total base is 6 minus x2. So I'll get that as 5.375 meters. This distance. Now I'll go on writing moment. So how will 50 kilonewton rotate about O? So 50 kilonewton will rotate in this manner. It will rotate like this, clockwise. So it will rotate clockwise. So I'll write this as plus 50 into perpendicular distance is what? Perpendicular distance is 2 meters. Then how will 120 kilonewton rotate about O? This will also rotate clockwise. So this will also rotate clockwise. So plus 120 into what is the perpendicular distance? Perpendicular distance is 2 meters. How will 30 sine 30 will rotate? 30 sine 30 will also rotate clockwise. So that is also plus 30 sine 30 is the force into what is the perpendicular distance? Perpendicular distance is this A. What is value of A? A is 5.375. So into 5.375. How will 30 cos 30 rotate about O? It will rotate like this. It will rotate anti-clockwise. So this is minus 30 cos 30 is the force into what is the perpendicular distance? Perpendicular distance is this B, or what is B? B is nothing but x1. So x1 is how much? 0.625. So solving this, I'll get not x1 is 1.08. x1 is 1.08. So solving this, I'll get moment about O as 392.56 kilonewton meter. So this is the moment about point O. Now I should calculate where is the resultant? Where is this resultant passing? To calculate that, what I require? I require this value of x. So what is x? It is nothing but the value of x-intercept. So how will I get x-intercept? So we have a formula to calculate x-intercept, which is x equal to what? Moment about O divided by summation Fy. Then I know moment about O is 392.56 and Fy is 135. We are using modulus, so it will be positive. So I am getting this as 2.9 meter. So value of x is 2.9. But to satisfy the condition of whether the dam is safe, what I should check? I should check what is 1/3 of B and what is 2/3 of B. So 1/3 of B is what? 1/3 of B is 1/3 into 6. 3 ones are 3 twos are. So 2 meter. Now, and what is 2/3 of 6? 2/3 into 6. 3 ones are 3 twos are. 2 twos are 4 meters. Now that we know what is 1/3 of B and what is 2/3 of B. So see here, I'll write here. 1/3, what is the dam to be safe? 1/3 of B less than x less than 2/3 of B. What is value of 1/3 of B? 1/3 of B is 2 meters and 2/3 of B is 4 meters. So this is 2 meters less than and this is 4 meters. What is our value of x? We are getting our value of x as 2.9 meters. So 2.9 meters. So whether our dam is safe or unsafe? Value of 2.9 is greater than 2 but it is less than 4. Means what? Dam is safe. Resultant is passing between the middle third portion. So this is how the application of Varignon's theorem is done. So hope you followed with this. So on the same line, I'll be giving you some examples for assignment. Take down this example. So same problem, a bit easier compared to the one I have solved. You can try this problem, take down the question and find out whether the resultant will pass and the dam is safe with respect to point O. So get the value of resultant, magnitude of resultant and the x distance. On the same hand, solve one more problem, which is again the application of Varignon's theorem. Question is again determine the position of the resultant with respect to point A. You have to check at what distance in x-axis the resultant will cut from point A. So try this one. So this is it for this session. Thank you very much.